We've always been told that in space, no one can hear you scream. Space is famous for one thing above all else: absolute, deafening silence. But what if that's not the whole story? What if our ears just aren't built for the cosmos? What if you could actually hear the universe? Would it be a beautiful symphony or a chaotic roar? Let's find out. First, let's get the basic science out of the way. Why is space considered silent? It all comes down to a simple fact: sound, as we know it, needs a medium to travel. It's a vibration that moves through particles, like the air we breathe or the water we swim in. When I speak, my vocal cords create pressure waves in the air, and your eardrums pick them up. Space, however, is a near-perfect vacuum. There are hardly any particles for sound waves to travel through. So, a massive star exploding a few million miles away, to our ears, it would be completely silent. No epic boom, no fiery whoosh, just a spectacular light show with the volume turned all the way down. But here's where things get interesting. Silence doesn't mean stillness. The universe is anything but still. Even in the vast emptiness of the vacuum, everything is in motion. Subatomic particles are constantly zipping around. Massive objects like planets and stars create powerful gravitational and magnetic fields that stretch and vibrate across enormous distances. Energy, in the form of light and radiation, ripples through the cosmos. These are all forms of vibration. They just don't create the kind of pressure waves our ears are designed to detect. So, the universe isn't truly silent. It's just speaking a language we can't hear. It's like being in a room with a dog whistle blowing. The sound is there, but it's outside our range of perception. The cosmos is filled with these unheard vibrations, a silent concert playing out on a scale we can barely imagine. So, what happens when we use science to listen in? Scientists have developed incredible instruments that can detect these cosmic vibrations. They can measure low-frequency radio waves, plasma oscillations, and even the faint ripples in space-time itself. And when they take this data and convert it into a range that humans can hear, a process called sonification, the results are breathtaking. It turns out, the universe has a voice. It hums. Imagine a deep, resonant tone that seems to come from everywhere at once. It's not a single note, but a chorus of countless frequencies, from the gentle thrum of a distant galaxy to the steady pulse of a spinning star. It's the background music of existence, an endless, deep hum that has been vibrating since the dawn of time. If the universe as a whole hums, what about individual celestial bodies? Each planet, star, and moon has its own unique vibrational signature. Thanks to probes like Voyager and Cassini, we've been able to capture the electromagnetic vibrations around our celestial neighbors and translate them into sound. And they are wild. Jupiter, the gas giant king, wouldn't just hum, it would roar. Its immense magnetic field and violent storms create a deep, booming, and sometimes screeching soundscape. Saturn, with its beautiful rings, would produce a more ethereal, hissing sound punctuated by strange clicks and whistles from its interactions with its moons, and Earth, our own planet, sings. The interaction of solar wind with our magnetosphere creates a chorus of chirps and whistles, while lightning strikes produce crackling bursts of radio waves that, when converted to sound like a cosmic choir. Now, let's talk about the most mysterious objects in the universe: black holes. For a long time, we thought they were the ultimate cosmic vacuum cleaners, sucking in everything, even sound. But in 2022, NASA released a sonification of a supermassive black hole at the center of the Perseus galaxy cluster. And it turns out, black holes sing as they pool in vast clouds of gas. They create pressure waves, ripples, that travel through the galactic plasma. These are, in a very real sense, sound waves. The note they produce is incredibly deep, about 57 octaves below middle C, far too low for humans to hear naturally. But when pitched up into our hearing range, it sounds like a low, haunting, and almost mournful hum. Black holes are not silent voids. They are the universe's deep, cosmic drums, beating out a rhythm that shapes galaxies. So, we've established that space is full of vibrations we can translate into sound. But what if we didn't need to translate it? What if, hypothetically, sound could travel through space just like it does on Earth? What would we hear? The answer is terrifying, unimaginable noise. The quiet hums we've talked about would be drowned out by a constant, overwhelming roar. A supernova, the explosion of a dying star, releases more energy in a few seconds than our sun will in its entire lifetime. The resulting shockwave would be the loudest sound imaginable, a cataclysmic boom that would shatter eardrums from light years away. Pulsars, which are rapidly spinning neutron stars, would sound like cosmic machine guns, firing off beams of radiation with mind-numbing regularity. Space wouldn't be a serene expanse. It would be a war zone of sound. Let's travel back in time. Way back, to the very beginning. What was the first sound the universe ever made? We can actually hear it. It's called the cosmic microwave background, or CMB. This is the leftover radiation from the Big Bang, the faint afterglow of creation. About 380,000 years after the Big Bang, the universe had cooled enough for atoms to form, and for light and sound to travel freely for the first time. The immense pressure of this primordial soup created massive sound waves that rippled through the young cosmos. We can still detect the echoes of these waves today in the CMB. When scientists convert this data into audio, what we hear is a faint, static-like hiss. It might not sound like much, but this is the oldest sound in existence. It's the universe's first whisper, the sound of everything beginning. So let's bring it all back home. Imagine you're floating in space, and through some miracle of biology, your ears could perceive every vibration around you. What would it be like? Forget the Hollywood silence. You'd be immersed in a constant, deep rumbling, a bass frequency that you'd feel in your bones more than you'd hear with your ears. This deep hum would be punctuated by the rhythmic pulses of distant stars and the sweeping whistles of planetary magnetospheres. There would be rhythms, but no discernible beat. It wouldn't be music, at least not as we define it. It would be the pure, raw sound of motion on a cosmic scale, a symphony of physics, played out across billions of light years. It would be overwhelming, chaotic, and more awe-inspiring than anything you've ever heard. In the end, our initial statement holds true. In space, no one can hear you scream with human ears. The vacuum is too vast, the distance is too great. But silence is not emptiness. Space isn't silent. It's just speaking a language our biology was never meant to understand, the language of gravity, plasma, and radiation. But with science as our interpreter, we are finally learning to listen, and what we're discovering is that the universe has been humming a profound, complex, and beautiful song since the very beginning of time. We just had to build the right ears to hear it. Thanks for watching. If you found this cosmic symphony as fascinating as I did, hit that like button and subscribe for more journeys into the unknown. See you next time.